Welcome everyone to the panel of our workshop in Cloud Intelligence AIOps. We'll take the next around 45 minutes to talk about cloud intelligence in academia as well as in industry. The topic of this panel is on how to accelerate AIOps work in practice and the collaboration across academia and industry. Cloud service plays an increasing important role in our daily life, and the quality of cloud platform, including the reliability, availability, performance, capacity, efficiency, security, sustainability, etc., has become critical important. Cloud intelligence AIOps is to infuse the AI and machine learning into the designing, building, and operation of high quality and high efficiency cloud systems at scale. Today, we are happy to have invited 4 panelists to attend our panel. Before that, let me have a brief introduction of myself. I'm the moderator of today's panel. My name is Qingwei. I'm a senior principal researcher and research manager from Microsoft Research Asia. I'm really excited to introduce our panelists here. We have panelists, 4 panelists. I won't go through the whole bio for everyone here as they are all very senior and experienced, and only by introducing their whole bio and experience will take us the whole hour. They've done so much work. Here I want to give a very brief overview here. Okay, going down with the alphabet order, I'm excited to get started. Would you wave your hand when I mention your name so everyone can see you there? The first one is Professor Deng Pei. Deng Pei is a tenured associate professor at Tsinghua University. Before joining Tsinghua, Deng Pei was a principal researcher at AT&T Research in the US. He is an ACM senior member and an IEEE senior member. We know that Professor Deng Pei has very rich experience in both the academia and industry. Next, we have Jean Kleewein. Jean Qingwei is a technical fellow in Microsoft and the director of development for the core M365 hosted services. He is leading the worldwide team responsible for delivering Office productivity services to hundreds of millions of people every hour of every day. Qingwei has worked on Office for more than 15 years. The third one is Professor Shan. Shan is a professor at University of Chicago. Her research focuses on software reliability and efficiency. Shan is an ACM Distinguished Member and an Alfred P. Sloan Research Fellow. Her authored and co-authored papers won a handful of Best or Distinguished Paper Awards in top-tier conferences. Our final panelist is Professor Tao Xie. Tao Xie is a chair professor at Peking University. He's an AAAS Fellow, IEEE Fellow, and ACM Distinguished Scientist. He has conducted a series of research that has produced high impact on the software industry, winning several awards from Microsoft, Google, Facebook, and IBM. Let's welcome our panelists again. From the panelists, we have very experienced and established professors from academia and also senior and distinguished technical fellows from Microsoft in industry. We expect to know the ideas from all the panelists here about their experience and knowledge sharing on the state-of-the-art research and practice, what are the top challenges and opportunities, and how can academia and industry work together to create high impact. Okay, without further ado, let's get started with the first question. What is the state-of-the-art research, technology, or practice of AIOps you would like to share or recommend, and why? I want to kick this off by asking our academic panelist, Professor Deng Pei, what do you think on that?
Well, thanks, Qingwei, for the introduction and also the question organizing this panel. Regarding the first question, I think right now researchers in both academia and the industry around the world have worked out quite a lot of solutions for all those individual components in this AIOps domain. But to be quick, in my opinion, right now is more about, putting all these things together and build a realistic system that can work well in practice. So in my opinion, towards that goal, we should combine, algorithm and knowledge graph and rule-based code and even human in the loop to put them together into the same architecture and make it a real system. That would make things really work. And towards that goal, we may need some standards that kind of define individual components so that the industry people can benefit from whoever is working on the individual components, and the academia can actually work on those individual components and contribute to the entire ecosystem. So, in my opinion, my answer to this question may be a little bit too coarse-grained, but in my opinion, that's the whole that the entire community should work on and work together towards this goal. That will really make a big impact on AIOps. Okay, so that's my short answer. Thanks, Qingwei.
Yes, thanks a lot, Professor Denpei. That makes a lot of sense, especially about the part of the standard among all those components and academia and industry work together to bring the path together. So also, what's your opinion about that, Professor Shan? Would you share your view here?
Sure, sure. First of all, I definitely see what Dan was saying. To be honest, a few years ago when this AI thing first started, I feel really suspicious. I feel like there are a lot of topics, like I've been working on, finding bugs for many, many years, and then suddenly see articles about, AI can write programs, AI can fix bugs, AI can do everything. I feel really suspicious. But to be honest, in the last few years, I do see that like this AIOps thing, it is making a lot of differences. In my system community, I see that in the past, I have colleagues working on resource scheduling, right? Particularly like in cloud, right? How to allocate resources, how to migrate workload, all these things. Many people have worked on this for decades, and then now it is true, right, that you have a lot of data, you analyze using data analytics, using machine learning, you can do much better resource scheduling. And I also see that I feel like using AI to write a code is a little bit a stretch, but indeed there are a lot of works, and there are also some great work from Microsoft. There was a recent best paper talking about using some analytics, right? You can, for example, predict what are the risks in every code commit and all these things. And also in my own research, right, I gradually kind of lowered my guard and become more and more open to this machine learning thing. So, and there were some topic I started working on since I was a PhD, building more and more complicated analysis, trying to detect bugs. And one day we just decided, hey, let's give up all those complicated algorithms. Let's just try with some very simple, kind of learning, right? A little bit inference, not necessarily deep neural network all the time, but just a little bit, statistics, inference. And it does turns out to achieve some amazing results. And we also got some best paper by doing things that way, bringing inference, leveraging the huge amount of code base that we have now, instead of using very complicated, program analysis. So I think these are the amazing things. But at the same time, I definitely see some of the things that, Professor Denpei was saying, right? How to put different components together. And then when we put different components together, you will need to think about how different things, how, for example, machine learning component and non-machine learning component compose together. And what kind of quality guarantee, right, do you get? How do you explain the results that you get? And also, I've also seen that instead of just saying, hey, I can use machine learning for everything, right? But rather say, hey, let's combine, right, some of those domain knowledge that researchers have obtained, right, through many decades of research, how to combine those domain knowledge together with machine learning. So I think these are all very interesting, active research that people are doing and will continue to do.
Yes, thanks a lot, Professor Shan for the sharing. Yeah, I can see that a lot of people also shared a very similar view here from suspicious to get some belief inside the AI. And also, there is a lot of challenge ahead of us. For example, you mentioned that explainability on the results and also how to get real landing into the real practice. Yeah, great sharing here. So, Professor Tao, would you like also add some comments in this question?
Sure. Thanks, Qingwei, for inviting me to serve in this panel and together with my distinguished fellow panelists. It's good to speak last among my peer academic panelists. I think both of them have covered quite well on those important current practices and even like upcoming period for AIOps in the future research or ongoing research. I just would like to elaborate on one point being mentioned by both Dan and Shan on combining human knowledge and AI technologies or data-driven solutions. Although nowadays we have many situations being monitored or implemented with footprints, right? The data being collected so that we could leverage advanced technologies, including machine learning, not necessarily deep learning, right? On such data being collected. But still, we have quite many activities, not necessarily easily or amenable for data collection, right? And like developer activities or like the different data, different kind of data being collected in different places and concentrating or consolidating the data in a single place could be a challenge, right? So I think having some kind of a form, I mean, which could be kind of like ontologies or some domain knowledge graphs for human to instill either implicitly, right, or explicitly the domain knowledge in the process. Recently, we had some collaboration with eBay on moving on that direction with industry system being deployed within eBay. With our latest result published or to be published at ASC this year by showing a deployed system for reflecting that nature, right, using event graphs for reflecting some domain knowledge in order to carry out some reasoning on causality relating the root causes and the symptoms. I think this is a very important direction. We have seen cases, I mean, in different companies for reflecting that direction. Maybe later, Jim will share some kind of like details about like some of those really advances going on in industry. Because I think later on we will talk about the industry academia. I feel like for this field of AIOps, industry is really leading with obvious advantage, right, with these AIOps and data-driven solutions. I will stop here. Thank you.
Yes, thanks, Professor Tao. The great sharing on the view on the data and also the cooperation experience with some industry companies here. So yeah, now we can see how it was viewed from the academia, and we learned a lot here. Next, we would like also to know more about the opinion on the industry side. What's your opinion on the state-of-the-art research technology or practice? Kleewein. please.
Well, thank you. First off, it's always difficult to go last in any of these discussions because a lot of the best topics are taken by people earlier than me, and they talk about some of the really major challenges that we've got, ranging from how to integrate data and processes for a lot of these AI-based systems that are evolving, and how to do it across the service lifecycle, because AIOps has to cover the entire life cycle from concept through deployment through repeated improvement. One of the things about hosted services is they're constantly evolving, and you really can't separate development from deployment, from monitoring, from operations, like a lot of really traditional old school systems did. So when you say AIOps, it encompasses a huge range of technologies. And man, Dan hit the nail on the head with that one when he said we've got to look at things like standards for how do we enable these systems to interoperate. I couldn't agree with that more. And then Shan hit some great points there too when she said, with AI isn't always the best tool, and deep neural nets aren't always the best tool to solve every problem. We've got to draw from a rich toolbox of different techniques and different capabilities. And we've got to keep the human in the loop, and we can't throw out a lot of what we've historically done to improve software, because this does encompass all phases of software development that we're used to. And then Tao talked about data. My favorite topic of all when we're talking about AI ops, because we know AI-based systems are only as good as the data training them, and only as effective and tailored as the data that's used to train them. And I love that. And I think he really hit the nail on the head with that for one of the biggest impediments to academia and commercial engagement on this is to do AI ops, you've got to have access to the data. But in a lot of cases, there's risk associated with access to the data because things like personal information can leak into the data. And then how do you make sure the data is clean and it's sanitized and it doesn't inadvertently have some of that personal data as we're sharing it with some of our academic collaborators to make sure that they've got real data to work from, so the results are real and good. But at the same time, we're protecting the privacy of our users and any of their data that might inadvertently get exposed. That access to data is one of the most powerful parts of the engagement, but it's also one of the most risky parts. And I think if I would pick any single technology advance, any single scientific advance that would really cause the academic and industry collaboration to just explode in AI ops and become the thing every grad student's got to work on and everybody wants to do their thesis on, is if we can invent technology to allow us to do this AI ops using private data in a way that guarantee preserves the privacy of that data. Whether that's a homomorphic encryption type approach or some type of differential privacy where you try to get an epsilon that's laughingly close to epsilon. I don't know what the right technology answer is, but man, if we can lick that data privacy thing, the world's our oyster as far as advancing this subset of the industry goes at just rocket fast pace. So that's the one place I would really love to see some advances. I'd really love to see maybe 5 times as many people getting their doctorates with disciplines and domains around privacy-preserving machine learning, because that unlocks the data, and by unlocking the data, you unlock the science. That's the key.
Great sharing. Thanks, Jim. Yeah, I personally especially like your points on that. Yeah, AI is not always the best tool on solving real problems, and also the relation between AI and the data, and also the points on the privacy. Great points here. Thanks, Jim. Okay, now let's go to the second question here. So, what's the top challenges and opportunities in AIOps research and practice. Yeah, anyone of our academia panelists want to take the question first? Yeah. Okay, Professor Dempei, please.
Sure. Yes. So right now, from what I can see, in AI ops, we can improve the quality of the software and the efficiency of, the software being tested and delivered and deployed, and also improve the cost of, operating the software. Of course, in these three major domains, there are different subtopics. For example, in cost management, we have traffic prediction, and also resource management, etc. But based on my own experience, I focus on the quality of the software. Therefore, I think the major challenges and opportunities over there are, the failure discovery, failure prediction, failure mitigation, and the root cause analysis. These are the major topics that people are working on around the world. And of course, a more recent trend is that among all those topics, people are working on instead of using individual data source to do failure discovery, now people are more working on multimodal anomaly detection. And also, instead of using statistics to do the correlation among different signals, right now people are more converted to using some, metadata, based on the call graph or causality graph, etc. So that all those correlations actually make operational sense, physical significance, right? And also on top of that, we can do all kinds of scenario-based algorithm. Basically, essentially, you have this recall of all the signals, and then you use metadata to do the correlation of all these signals. And then on top of that, if you think about it, failure mitigation, root cause analysis, failure prediction are all using all those signals and the correlation. So why don't we, do these things in a, more principled way, so that all the signals are collected, different people can work on those signal recall techniques, and then, we do the correlation in, based on metadata instead of just simple statistics. And then on top of that, all those algorithms are actually enabled. Instead of each individual algorithm, you have to do your own signal recall and all your own correlation, right? So, if we can do it that way, it really, I really want to echo Jim's point, right? So basically, not just the data, sanitization that enable this, but also if we can give all those researchers kind of a big architecture, and what they are working on is in this big architecture, and then I think all the parties around the world will converge and actually work together instead of working on individual piecemeal. And then if we are enabled with some kind of large scale sanitized data, especially those metadata that is used to do the correlation, I think it will enable a lot of things as Jim envisioned. We will soon get a boom of this AIOps research. Okay, that's all. Thanks.
Yeah, that's awesome. Yeah, thanks, Professor Dempei. Yeah, I see that you mentioned a set of hot topics people are working on, like the detection, root cause analysis, causal reasoning, correlation analysis for prediction and smart mitigation. Yeah, great sharing here. Thanks. Professor Sanru, would you also like to share your experience here?
Sure. Yeah, so I think Dan mentioned a lot of amazing directions, failure discovery, root cause diagnosis, and I think those are exactly, the research that will make all my PhD work become, I wouldn't say garbage, but so recently my group, so we have also looking at kind of failure discovery, root cause diagnosis, but not for traditional software, but for those software that contain a machine learning component, right? So you can use machine learning to help you to diagnose those traditional software. But now with more and more software that use machine learning, right? Those new kind of type of software itself, right, present new challenges to failure discovery, right, root cause diagnosis, and just something very simple. Like once you introduce a machine learning component, right, and then it's hard to tell, right, if the result is not what you want, right? Like if you want to say, I want to know that, oh, this photo should include a dog, but my software that contains a machine learning component doesn't tell me it has a dog. Is it because that machine learning model is not strong enough, right? Or is it because my input, right? I did not submit my photo, right, using the required resolution, right? Or is it because the developer, right, they didn't read the API manual, right? They didn't read the, the Azure or the Google Cloud ML API manual correctly, so they use the API in the wrong way. You don't know, right? And then the root cause diagnosis it suddenly becomes really complicated. You have to do not just a traditional, right, code analysis, dependency analysis. You also need to understand, right, part of the machine learning model. And sometimes you just don't know, right, whether do I judge this as wrong, right? Is it something wrong? Or maybe it is still fine, right? So there's just a whole new set of challenges. And also we actually studied, like, for example, looking at those open source applications that use machine learning. And you will be surprised, like almost half of the software, they're using machine learning API in a wrong way, right? There are just many developers, right? Because, part of this, when this AI ops thing become more popular, right? A side effect is many people think they know how to use machine learning, right? And then there are many developers, for example, they don't know what's the difference between image classification and object detection, right? And then and they also don't know that. I think actually Jim, Dan, and Tao, you all mentioned, right? A lot of how your machine learning component work depends on the training data. And the many developers, they don't have the sense, right? What are the training data, and what kind of data, right? It will be suitable. So that's a big, big domain. And looking at those software, the quality of those software that use machine learning is kind of scary, right? If really one day we say, hey, every software will use machine learning, it will be very scary. I mean, the quality would be very bad. And in the past, it's easy to some extent, right? When human make a mistake, you can identify, oh, you made a mistake because at this line of code, you had a typo. Right now, with a machine learning, use a deep neural network, you cannot even pinpoint, right, what exactly is wrong. And I will just quickly say another. I just want to say, although everything machine learning, but at the same time, in order to support all these AI ops, we need a lot of cloud resource, right? That is doing actually traditional data analytics, right? Data sanitize. And just to do the work of doing all those deep neural network computation. So actually there is a big challenge in terms of again reliability. Even just going back, right, for the cloud reliability itself, there's a huge challenge there. Is machine learning cannot solve all the problem, and just a lot of research is needed.
Great sharing. Yeah, thanks, Professor Shan, especially on the points on the relations of machine learning and AIOps and the experience of the developers in real practice. Yeah, the rights and the wrongs and a lot of real challenges here. Awesome points. Thanks a lot here. Also, Professor Tao Xie, would you like to add your comments here?
Sure. I just would like to add two additional points. The first point is on collaboration among the engineers or operation engineers together, right? So-called cloud intelligence. How do we enable cloud intelligence in this setting? We all know, like Fred Brooks, the mystical man month. You adding more engineers into the team, you don't get proportionally the return in terms of the outcomes, right? I think even in these AIOps or operational engineers situation, that's even more true, right? Because often the time, the engineers would have their knowledge inside their mind, right? When they are doing the debugging, and they don't have a convenient way to articulate their findings, right? At this point, even when one engineer couldn't solve the problem, but how could we communicate, right? That knowledge to other people who would like to help out, right? Because when the incident under investigation is very urgent, right? And people would like to solve them when adding more manpower, but how do we enable them, right? Besides adding more machine power, right? Using cloud to really ease the computational power side. I think that's a quite open challenge or area that we may not see a whole lot going on, but I think it's very important. It's kind of like a bit far-fetching in terms of the challenge ahead of us. I think that's the first point I would like to add is that the collaboration among users of the AIOps technologies, right, to enable the cloud intelligence. The second point is on trust. We all know data-driven solutions cannot give you 100% the accuracy or the results. In some critical situations, it's very important for us to make sure the solutions that we have would be really the right one, right, or the ideal one. Often the time we may not be able to distinguish the two cases, right? And we may have a solution, we put it out, it works now, that let's hope it's the right one, right? So especially when you have the automation, even when you're human in the loop, right, the judgment or determination of the ground truth or the oracles would be quite challenging at times. I think that's a real challenge or another challenge ahead of us, right? How do we really work with an imperfect solution, which is a data-driven nature, right? Which means that it can output incorrect results from time to time. I will share these additional 2 points. Thank you.
Yeah, great. Thanks, Professor Tao Xie. Yeah, I love your points on the return and the outcomes, especially from the perspective of the software domain. And also the points about the trust is very critical. Yeah, great sharing. Thanks. Let's also listen to the points from our industry panelist, Jim Kleewein. Jim, what do you think on the challenges and the opportunities?
Well, I kind of cheated because I worked my challenge into my first part of the talk with PPML. So I'll give you what I think the second biggest challenge is that we face. I think everything my academic colleagues have said, I totally agree with unreservedly across the board. I think that I'm going to add one to what they said, which is zero-shot learning. We process billions of documents a day, trillions of user interactions a day. The common problems that emerge, the 4 nines percentile, the 5 nines percentile problems, we see those on a daily basis, and we've built software to address a huge percentage of those already. What we see now are the really long tail of problems, and consequently what we need in a lot of these cases are models and systems that generalize super well, that work very well in zero-shot environments, because when we see problems that occur, we build remediations against that problem ever happening again. So in the vast majority of problems, it's something we've never seen before. It's something there's no data to support to allow us to learn from. So it's really how do we build these models so that zero shot kicks butt, and that we really nail that, so that it'll be able to react to things it's never seen before, because that's kind of when you're processing trillions of things a day. That's what you get to. You get to that long tail really quick. And how do we nail that long tail? That's the second biggest challenge after privacy.
Yeah, thanks, Jim. Yeah, zero-shot learning is a very critically important research area. Yeah, great point here. Thanks, Jim. So yeah, now we've got the information of the state-of-the-art technologies, the top challenges and opportunity in your mind. Now let's go to the third question. According to your experience in cloud intelligence AIOps, what are the difference between the academia and industry in terms of doing research? How can we better accelerate the collaboration between the academia and industry and make a greater impact on both sides? Same order. Yeah, Professor Dempei, would you share your points here?
All right, thanks. Well, I think your question has two parts. What's the difference? Right now, my best opinion is that there's not a lot of difference because academia and industry are working together to solve AIOps problem. It's rarely seen that academia work on their own because they don't have data, right? So that's the easy part. But on the other hand, how can we work better together to solve real world problem? I mentioned earlier enough about building an ecosystem, etc., and making all those standards. And just to add a little bit more, I think industry in a better position in building some infrastructure for the research, AIOps research around the world. For example, right? Industry have the data. Why don't we provide all those data serving interface, right? We have, as I mentioned, if the correlation need to really take advantage of those metadata, right? And what metadata available and can be used are based on domain knowledge. Who have the domain knowledge? I think the industry have more domain knowledge, of course, right? So why don't we actually make all these things as a kind of platform, and so that all the data and the raw data and the metadata, right, used for AIOps research are there. Of course, we have to have sanitization, and of course, we do have to enough data quality and signal in the data. And on top of that, I think that's where academia can really contribute, right? So we know what we should work on, right? Because we work together and the industry take lead to define the problem to work on, and what are the data needed. And then on top of that, we can access the data based on, we have problem to work on, we have the input to work on, we know what the industry wants from the algorithm as output. Then you can think that, it's really we work as a whole, as a community towards the same goal. So that's kind of some direction that I'm advocating. In the past, I tried to, for example, organize some AIOps algorithm computation. One side effect of that, and which is also part of my goal, is to, I work together each year. I work together with some industry companies so that they contribute the data, and I provide the problem, and so that as a result, we publish some data every year for a specific topic. But that's too slow compared to what the industry, what the world require from AIOps. So that's why I'm advocating this ecosystem, whole community approach. All right, thanks.
Yeah, thanks, Professor Dempei. Yeah, we know that you have a lot of experience in both the academia research and also the industry research in ops domain. And yes, there is a lot of synergy here. I agree on that. Professor Shan, would you also share your view here?
Sure. I mean, I feel like both Jim and Dan already said it very well. So I will just maybe share a kind of small story from, of my own experience. A few years ago, my group have been working on, trying to detect timing bugs in distributed system, and we published a lot of papers, and we're very proud. And I chatted with someone from Microsoft, and he just told me, I don't think it works in Microsoft. Our code will be too complicated for you to analyze. I didn't believe. I told him, but I am using, like those open source distributed systems. Those are real open source distributed systems. And then my student did an internship in Microsoft, and in like 1 week, we know that indeed our technique does not work. And of course, it's great, and after that, we came up with a better solution, and it's actually much simpler, but it turns out it works much better in the real world. It was a really big lesson to me. I know, right? I knew that industry. I need to ask my industry friend, but I didn't know that there's still a lot of things. You just have to really need to experience. You need to see the real code in industry. You just see, those like say cloud incident. What kind of incidents actually happen, right? You need to see the data to understand the research challenge. And of course, this goes back to James mentioned, right? There need to be some kind of sanitization so that there can be better collaboration, in addition to just student internship. So for myself, I'm visiting Microsoft now, and it's just really, really help. It benefit my own research a lot, and I really appreciate it.
Thanks, Professor Shan on sharing her own experience in real practice. Also, welcome all the students to do internship or visiting in Microsoft. I promise you that you can learn a lot here. Thanks, Professor Shan. And also, Jim, would you like also share some of your points here? Oh, sorry, I forget Professor Tauxie.
Already.
So,
well
said. Which of you would like to take that first?
Okay. I think I would like to add a somewhat different angle. I agree with all have been said in terms of the importance of visiting Microsoft, right? And I myself visited Microsoft research for quite some time. Working with Qingwei on this AIOps. In the old days, probably AIOps was not popular yet, right? So working on this important problem. I think, of course, this is very important and critical, getting hands-on real data, real system. But at the same time, I think us, a research community, we should try our best, right, on the side to expand channels or ways of carrying out research for academia. I just would like to add one example that I got involved with the lead as a researcher from Fudan University, led by Professor Xin Peng. Several years ago, we looked around on the open source communities in terms of medium size, not to say large size, microservice systems, right? And we all know microservice systems are commonly deployed in industry. But in the open source, we don't have large enough, right? Typically at the time, we look at only like a few microservices in a single system. At best, like 10, no more than 20 microservices. So, of course, this tiny scale, not to say small scale, tiny scale of the microservices would hardly reflect characteristics or the real challenges in industry, right? Especially, for deployment debugging. We know it's very difficult for companies like Microsoft to release, your systems, right, large-scale systems as open source. But I think we can together make some efforts. At that time, basically, Professor Xin Peng led a large group of graduate students to develop open source mid-size Microsoft systems. With around, I think at the time, more than 70 microservices for a system called chain ticket, basically simulating the user experiences of buying fast chain tickets in China, right? So it's not large or large enough, I mean, to reflect real industry practice. I think with some careful tooling and, for example, for fault injection, right, and along with some careful workloads construction for these open source systems, we still could deliver some useful scenarios or situations for the academia to work on. At the time, we interviewed a dozen of companies to collect real incidents and real faults from them on their own microservice systems, and then we reproduce such or simulate such faults and the workloads for like exposing the incidents in our mid-size microservice benchmark systems, and that indeed helped quite some researchers to jump in, right? And because that's the advantage, right? Not just the data, right? Because that's, I mean, when we work on data, the domain knowledge, I mean, the system for producing the data would be very important. So just releasing the data itself, it helps, but often the time it's not enough, especially, I mean, for people to instill the software domain knowledge, right, into the process of constructing useful technologies to solve the problem. But I agree, we should acknowledge the limitations of such benchmark systems, but we should also expand our horizon, I mean, on such efforts, besides putting our bets on companies like Microsoft to allow us to visit. Thank you.
Yeah, thanks, Professor Tao Xie. So we have only 1 minute left. So Jim Kerwin, would you like to answer this question using this 1 minute, and also use it as the closing?
I will close, and I'll make one very, very short comment. And my very short comment is industry desperately needs academia to remain engaged on this problem, because you look at the world differently than we do. We tend to be overly pragmatic in how we approach every problem. You don't bring that baggage. You bring a new way of looking at things, and we desperately, desperately need you to work with us on this.
Thanks to the wonderful panel discussion with Jim Kleewein, Shan, Tao Xie, and Dan Pei. We hear voices from both the academia and industry, and thank you for taking the time for sharing the rich experience and knowledge with all of us. Thank you.
Talking to you.
Thanks.
Thank you all.
Thanks.
Thank you.
Thank you. Bye-bye.
Bye.